Hey, welcome back. I'm just double checking our sound and our connection. Looks like we're connected. In a second, I'll make sure sound is working. I was having a little bit of trouble before. In a second, I'll make sure sound is working. I was having a little bit of trouble. Seems like we're good. Cool. All right, so the latest and greatest is that we had the submission for project number 2, looking at New York Stock Exchange, a little bit of data analysis, a little bit of Monte Carlo kind of prediction methods. I love Monte Carlo methods because it's kind of like the engineer's like hands-on programming approach to doing statistics, where you get to like play around with how random variables affect things, even though we're using like very like not easy to understand, but it's like equations that I can play around with. So jumping into the project, and here, let me make another copy. And we'll change this over to winter. So first thing that came up is somebody was having a problem with this piece of code that said format ISO 8601. Let's see if I get the same error. Yeah, so it's telling me that it doesn't match this ISO 8601 error or like thing. And the quickest way to do that is like, all right, and I don't know why it doesn't work right now, but if I comment out that specification, then it does turn those date times into actual like date time formats. So it does get us to the right point. And then it seemed like there was still like some ChatGPT work, and again, like it's totally fine to use ChatGPT, but recognize that its limits. It's very much a transformer. That it's almost like it's not almost like, it is the same algorithm as like that next word prediction on your Apple or Android keyboard, where it's saying like, I want to, and then the next thing is saying like go. That's all this is that it's a next word predictor. It's just using like lots of different things to try to predict next words, and it does that even for coding. So sometimes it works really well, other times it doesn't. You really need to like assess, is it going to work? But the reason I bring that up is that here we're trying to dump in 850,000 lines of information. So if you try to just download this and tell ChatGPT, take a look at it, it's a lot of data for it to parse through, when probably all we need is like maybe 5 lines of it. Like we could probably just truncate it and it would be able to figure it out and give us some kind of information. We don't need ChatGPT, at least to get the first analysis kind of done. I can run through this, and in this case, I'm giving some, again, like kind of a cooking show analysis where everything's set up for you, and it's so if you want to cut the data at this same point, you can. If you want to try it at a different point, like if you want to look at January 1st instead of March 1st, it'll change where we're cutting it off. So maybe it'll do a better job predicting this little jump up, since we're capturing most of that growth in here. So we can try that. And one of the key points to this random walk model is that if I take this opening price data, so if I take all of this data, just copy this, let's make a new and let's make like 20 bins. If I look at a histogram of the actual prices, there's not a normal distribution, and in no there's no way that I could try to make the claim that this is a normal distribution, because there's definitely something happening over time. There might be a lot of things happening over time, like there might be other factors, and some people tried to say this in their analysis, is like, hey, there's other factors not involved here. And if you think that is true, but what are those other factors and how much of an impact do they have? Like in this case, this drop is due to the fact that Google split. Like I think it went from Google to Google plus Alphabet in 2014. So if you want to say that, you can say like splitting a company it went from 1,200 down to 600. So it took that $1,200 and split it into two $600 stocks. That's something. So if you split a company in half, your stock price divides in two. That would be like a great way of saying these are things that a random walk does not capture, because it's not thinking about, did the stock split into two stocks? But you want to be quantitative. As engineers, you get paid for the numbers and your analysis of numbers. Just kind of throwing ideas out there that doesn't count. Like I could say anything that I want, like the moon affected this data, but if I don't have real quantitative information saying like every peak here corresponds to a full moon, then one, it's probably happened, like probably not even true. But two, if I don't have the data to back it up, then it doesn't exist. So that's something hard, and that's why I give this assignment, because it might be the first time that you're really practicing trying to say something quantitative with some data. So I set it up so that you can kind of run the analysis and then think about like, what does this analysis mean? Okay, so we've got the price itself is not normally distributed, but if I look at the change in price every day, this looks like random noise, at least to me. When you see a signal that's kind of jumping up and down like this, maybe there's something like high and low frequencies happening in here. We could try zooming in. Actually, do I know how to zoom in on this? I don't know how to zoom in now that I'm thinking about it. D price. So we could just do like 1 to 20 and 2 to 20, or 1 to 20, something like that. And let's do like 100, maybe 100, see if there's anything. And there again, like I don't see anything. If I just look at 100 data points in here, I don't see anything that shouts like, oh, look, the change in price is a function of time. Like either it's a sine function or an exponential curve or anything like that. So it seems like there's something random in that change in price. And that's what this graph is kind of showing me. And so if I'm assuming that it's random, one way to capture random information is take the mean, take the standard deviation, and see if a normal distribution matches the histogram of all the measured changes in price. And it's not bad. There's like this extra spike, a little bit less than $0, but it seems like this red curve is mostly capturing these blue bars. If you don't agree, then that's totally fine. Like maybe you don't think that this does capture it. Maybe you think that there's some other, instead of a norm distribution, maybe you think it's some other distribution, like Weibull or any others. And there's tons of different like statistical distributions that you can think about. So then you don't have to set a seed, but again, the seed helps you just recreate so that this data is always the same data. This and like this specific first model is going to be the same. It's going to be the same random numbers each time. And yeah, again here, it kind of looks like we're getting the same thing. I can increase the number of models if I want to like bump it up to 500 or something. It won't really change what this model prediction looks like here, but it'll change what the average and standard deviation are as I move down through here. So here I bumped it up to 500 different models. So let's look at those averages and standard deviations. And what I can see here is that for the most part, the growth on average is a straight line. And I'm skipping, like, I'm going like every 100th, but I could skip to every 50th day. And for the most part, it's always, every day is increasing by that average amount. So on average, my growth is, let's come back up here, 0. So on average, I'm growing 50 cents a day. So throughout the year, it's going to be 50 cents times 365. That's my general kind of prediction for this model. So then I can make, since I have that, one, I can look at this data and say, all right, is this black line part of these analyses? And if I look at these red lines here, yeah, let's just actually zoom out and open it in a new tab. There, that's a little better. So if I'm looking at this data, a lot of the black line is maybe 1 standard deviation away, but it's always within like 2 standard deviations of my average. So all these different models that are being created, the red dots are the average value, and then these bars are the standard deviation. So by the very end, I have a very accurate model where I'm predicting whatever, let's call this $1,200, and the actual price is $1,160 or something. So it's within like $50 on this scale here. Or you can even, because we have this price model average, and we have that actual price. If you want, you can say, oh, whoops. I can take the actual Google data and subtract it from that price model average. And now I can see the exact, how much of an error did I have in here, where I'm saying like this was the actual opening price, subtracting my model average price, and by the end of the model, it's within $100. So this is a very accurate model, but it's not a very precise model because my standard deviation keeps getting bigger. We can see at the very beginning, it's all within like $50 or $60 in the first couple of days. But by the end, I'm saying that the price of Google could be $1,000, or it could be 0, or it could be 2,000. Like that's a very wide range of predictions. So I do not have a precise model, but I do have a very accurate model where it's within $100, even 4 years after I started predicting things. So accuracy, precision to the things. And again, I have like a quantitative measure of like, what is the accuracy? Here's my accuracy. And then I could look at plt.plot this for price model standard deviation. I can see that my standard deviation starts off again around like $10 to $50 in the first month or two, but by the end I'm looking at 300. So when I'm off by $100, it's also 100 plus or minus 300. $100 difference plus or minus 300. So the precision keeps getting worse the longer I'm predicting something. So like doing this and now, whenever you pick your own stock, like you can grab any of these stocks and run the same kind of analysis. So you would go back up into here where, and what I'm gonna do is let's just copy all this stuff down to here, and I'm gonna paste it down here. So I'm just literally copying and pasting all of those things so that now I can say, instead of Google data, I want to look at maybe PEG. I forget what PEG is. And I want to take all these PEG like that. PEG. Oh, interesting. So something happened with this PEG as well in 2014. Let's see. Public Service Enterprise Group. So it's a gas utility. Interesting. So something happened in 2014 where there's a big jump and then it kept growing. And yeah, right there in January for some reason. Kind of cool. So here, and yeah, I don't need the opening price here, but I want to look at this. PEG. And again, to me, when I look at this from 2010 to 2014, it doesn't look like there's any growth. Like, it's very different from this curve. I guess that's what I'm saying. In this curve, it looks like I could probably take a straight line and say it was growing on average by an amount. And then on this one, maybe it was growing by another amount. But when I look at this, there's no real trend as to like what was happening each day. So we'll grab that, PEG, like this. And this was one of the things that I noticed is that when we're kind of trying to look at this, this scale is like way too stretched out, because a lot like PEG, we can see coming back up here, we're talking about $30 to $50. Meanwhile, Google was coming all the way, oh, 500 up to $1,000. So it was a very different scale of what was happening. So instead of saying that I want this lin space to go -40 to 40, I probably only need like 5 to 5. And now I'm zooming in a lot further, and even that's a little too far out. So let's go -3 to 3. And now it looks pretty close. Even that's a little too big, right? Because we're talking about like 3 standard deviations is only $1. Like it's because 36 cents, a dollar or something. And on average, there was no change in, and maybe I want to pull out like 5 sig figs. So on average, there was a 1/10 of a cent change every day, and a negative. So it was like losing money, not losing money, but its stock price was dropping. Doesn't necessarily mean that the company was losing money. And that always seemed weird to me, that if a company is losing money, it can still be increasing its stock price. But that's for a whole nother time. And let's grab all this stuff. Everywhere we see Google. PEG. Oh, and here's another place where I saw things run awry. It's like my model prediction looks very different from my my histogram and my data. And the reason for that is that this, and I like to put these on, this location and this scale are still set on Google changes in data, Google changes in price. But meanwhile, I could grab this mean D price and STD D price. And now it looks a lot better, where this yellow, these yellow bars are a lot closer to those blue New York Stock Exchange data. And again, we're going to come in here, change all of this to PEG, like that. Let's see what happens. Cool. So it looks like it's predicting something. Again, the predictions have very low precision, but very high accuracy. At least I think they're high accuracy. I'm going to change all these. And if you're wondering how I'm getting all these things, if you hold Control and keep clicking on places, then you get multiple cursors like that. We'll take a look when this pops out. And sure enough, now this PEG price is always less than 1 standard deviation away from the predicted values, which is that's pretty awesome. So this is a very accurate model for things that are not changing a lot. And we can see that here, is that we're always within $4. If I take, oh, whoop, sorry, PEG, and then PEG. Yeah, so we're always within $4 of that price model. And then in here, and our standard deviation starts around $1 and then rises up to $12 after 4 years. If I want to keep predicting this into the future, what I can do is say, rather than making a D price model that is the same length as my pre-2014 data, I'm going to make it the same length as the whole data set. It's not going to make a big change in my histogram. It's just creating more price differences. And now when I look at my price model, I can actually extend it out into the future. And I can even compare it to the real data. And this one, it's going to be the same starting value either way. Let's see how that goes. And now what I did was I used the price data from 2010 to 2014 to predict into the future. And all of this, the 2014 through 2017, is now what's called like testing data, where I had the data, but I didn't use it in my fit. And again, we're going to take all of these pre-2014 stuff and delete it like that. And I want to delete all of this one too. And now what I can see is a difference between what was happening in those first 4 years versus what happened in the next 4 years, where my model is still capturing. So as I look at these predictions, kind of extend them into the future, that these first 4 years are always within, like, the worst case is that I'm $5 off, and that's not bad for 4 years out. Like on a $40 stock price, I'm within 1/8. But then once I hit that 2014, something changed with PEG, and my model is no longer capturing what's happening. So now I'm getting to like $10 off and $15 off, which becomes a bigger deal when you're talking about. So the error keeps getting worse as I keep going into the future. So although it's within 1 standard deviation of that, and here if we want to look at like the relative values, like is it 1 standard deviation or 2, I can also say divide by price model standard deviation. And I can see here at first some of this is kind of weird because the standard deviation is so small to begin with, but I'm always within half a standard deviation up until 2014, when it keeps growing. Now I'm half, now I'm 1, decreases a little bit, but back up to 1. But that's the kind of analysis that you can use with this model. It's like, so we built something, what can we say about it? Are we predicting something worthwhile, or is it just sort of like playing with numbers just because we love like finger painting with numbers? And there's a lot more to it than just like nothing. Like, we did the work. Now what does it mean? I think that's the hard part. At least when I was an engineering student, I struggled with like, what does this actually mean? So I want to give you a chance to like try to struggle with that now, so that the next time someone asks, you have a little more insight. Cool. And so with that, this is the end of module 2, and we're jumping straight into module 3, where now we're getting back into some physics models. So not as much, a little bit of data analysis again, but now we're going to start doing like physics prediction. So we'll have engineering models like F equals ma kind of stuff, and we'll start solving differential equations with Python. It's pretty cool. Save you some handwriting of like solving things out by hand. Cool. All right, I'll see you next time.